Yes, class, is this audible to you people?
Yes, ma'am.
All right. Okay, so in the last class, we had started with this topic, capacitance. Last class, which extra class we had. Madiha, were you not aware of the extra class that we had? Means, did you get the information about it?
Ma'am, I didn't know, so like I wasn't able to join. We got it early in the morning.
Okay,
Yes, keep on.
all right, fine. See, in capacitance for the new students as well, Abia and Sahel. Sahel, your pronunciation is right? Sahel, it's or
Yeah,
Sahal? Sahel.
Sahal.
Sahal. Okay. See, we had started with capacitance. So I hope you people are aware of the term capacitance. Yes or no?
Yes, ma'am.
And what about you, Sahel?
Aware, I'm aware.
Okay. See, capacitance is the ability to store charges. Electric charge we have studied. So the ability to store these charges, that is known as capacitance. And the device that does this function of storage, we call it as a capacitor. So capacitor is the device that stores the charges, and this phenomena of storing the charges, this is known as capacitance. So in yesterday's class, we had an extra class actually. Yesterday we had an extra class where we completed all the 4 cases. So first case is what? Let me tell you briefly. For the construction of a capacitor, you have to have 2 conductors with any medium between them. Mainly it's a dielectric medium that is placed between them. So the formula that we get, if the medium between the plates of a parallel plate capacitor, if it is kept completely filled with air, then the formula that we get, this is epsilon naught A by D. This is the formula. Epsilon naught is the absolute permittivity of free space. Fine. So absolute permittivity of free space, whose value is 8.85 into 10 to the power minus 12. All those who are not aware of this, don't worry, we'll study it again. A is the area of the plate. D is the separation between the 2 plates. If these are the 2 plates, then this separation between them. Now, dielectric constant is a term that gets added. Dielectric medium is basically an insulating medium. So if the insulating medium is there, the 2 plates are kept in an insulating medium, then multiply it with a constant K. So your formula of capacitance, if the 2 parallel plates, these are completely filled by a dielectric medium, it becomes K epsilon naught A by D. Then if it is partially filled with a dielectric slab, like in this manner, like this, not completely filling it with a certain thickness in the middle of the parallel plates, a dielectric slab has been inserted. If such is the case, then your final formula, this becomes C is equal to epsilon naught A divided by T plus T minus T by K. In this, T is the thickness of the slab, A is the area, small d is the separation between them, K is the dielectric constant, and epsilon naught is the absolute permittivity. When we'll be having the backup classes, most probably from day after tomorrow, we'll be having the backup classes as well. There we'll discuss about epsilon naught, means absolute permittivity. Because you have a term absolute permittivity in permeability in magnetics. So even when we'll move on to magnetics, you people have to relate with electrostatics. So we'll try to complete the backup before it. C is equal to epsilon naught A by D minus T. This is this final formula, fourth one. This is when instead of the dielectric slab partially filled, you have the partially filled conductor. A conducting slab is there. So we did a lot of derivation. So Madiha, I think I'll suggest you to take the recording because it was I think 1.5 hours class we had. So the 4 derivations we did. So for the derivations, I would suggest you take the recording. Either take it from the team, ask the Learnivio team for the recording, specific recording. If you're not able to get it, then ask me. I'll send you on the WhatsApp group. And Abia and Sahel, are you both people added on the WhatsApp group right now?
I'm not sure. I'll have to check with my father.
And Abia?
No, ma'am, I'm not.
You're not added. Okay. All right. Now, energy that is stored in a capacitor. So all those people who are new, since today is your continuation class of the last class, so If you are not able to understand any term, just ask me. I'll try to explain it. Otherwise, we'll have the full classes of it. Now, energy stored in a capacitor. Let's say this is a parallel plate capacitor. As I've told you, capacitor can be of any shape. But parallel plate capacitor has basically a rectangular plate. 2D plate is there, which is connected to the positive terminal of the battery to make it positively charged. The next plate is connected to the negative terminal of the battery to make it negatively charged. So you have a parallel plate capacitor. Let's say total charge on this is Q, and total potential, that is V. Now, all the work done gets stored in the form of potential energy. So we are calculating the energy that is stored. So if we are able to find out work done, then we can easily find out the energy. Because what will happen? All the work done, that only will get stored in the form of potential energy. So for that, let's just, or even remember when we did it for energies, different energies, we had always seen that work done only gets stored in the form of potential energy. When we were discussing electrostatic potential energy, there also we saw whole work done got converted into potential energy. So if we find out the formula of work done, that work done we can equate it to the energy stored in a capacitor. So we have taken a very small amount of charge, dq, a very small amount of electric charge, and let's say potential on that smaller part is v prime. V prime is the potential on the smaller charge. A smaller portion of the total charge is being taken. Work done is dw. Now, from here, potential will be what? It will be dq by c. Why it will be dq by c? Q is equal to cv. Charge is equal to, this is the formula of charge. Or you can say the formula of capacitance you can write. This is Q divided by V. From here, we have derived this formula. So using this formula again, you can find out the potential. Potential will be equal to what? Potential will be equal to charge divided by capacitance. So that smaller portion potential will have the charge smaller dq divided by the capacitance. So dw, the work done, this whole work done, this will be equal to what? This will be equal to q dq, now divided by this c. And then we have to integrate it from 0 to capital Q. We are integrating it from 0 to capital Q. If anyone has any difficulty in integration, then just write me in the chat box, because in the 11th classes batches, right now integration is going on. So if anyone has time over there, then you can join the batch. So if anyone has problem in integration, not differentiation. Differentiation has been completed. So if you're having difficulties in integration, then you can join the batch for one class, I think. All right. So this is Q dq divided by C. Now, according to the rules of integration, x to the power n, that becomes x to the power n plus 1. So it means Q is there. Q is having the power 1, so it will become 1 plus 1. And whatever is the power, that comes in the denominator. And then you have 1 by c as well, and limits are from 0 to capital Q. And the total integral of work done will give you the complete work done. So this becomes what? This becomes Q square. This becomes 2. This becomes capacitance C. Here you are having the charges from 0 to capital Q. This is the value of it. So work done is what? First put the upper limit and whatever is the power. Subtract lower limit, whatever is the power. We have discussed integration so many times, and we are discussing potential as well. That time also we did discuss, as well as when we began this chapter, electric potential, then also we discussed differentiation and integration. So if your people are not able to recall, text me. I'll explain you again. Now, 1 by 2c, keep it aside. This is a constant. Upper limit is q square of whatever is the variable. So this becomes q square minus lower limit, that is 0, square of it. So final answer is what? Final answer is q square divided by 2c. And this work done gets stored in the form of potential energy. So energy is what? Energy becomes q square divided by c. This is the formula of energy. Now, this is in terms of what? This is in terms of charge and capacitance, Q and C. If we have the formula in terms of, or we have only information of capacitance or voltage, then how to solve it? Or if you have the information of only capacitance and voltage, or voltage or charge, then how to solve it? This formula is valid if you know charge and capacitance only. What if other quantities are mentioned to you? So just replace it. If you replace Q is equal to CV in this formula, you will become what? C square V square instead of Q square divided by 2C. C half the square and C gets cancelled. Energy becomes half CV square. This is an important relation. All these three are important, but half CV square is mostly used in the circuits. We in the next class most probably we will be studying the circuits where capacitors are connected in series, they are connected in parallel. There you will be asked to calculate the energy of a specific capacitor. So half CV square is mostly used because we are aware of the potential and the capacitance. Now this is in terms of CV. What if we have to write it in terms of Q and V? So we can replace C. C is equal to what? Q by V. Put it in the formula. It's Q square divided by 2 Q by V. So Q gets cancelled. U is equal to QV by 2, half Q. This is another formula. So these are the three formula for energy. All the three are valid. You can use any of them, whichever data is given to you. Now the numerical one was left. Remember on these four capacitance, the four formula that we discussed yesterday's class, we didn't do any numerical. No, we had to do the numericals. So we'll do the numericals right now only. But before that, just note down this energy portion, energy of the capacitance. And wherever you are having doubts, you can unmute yourself and ask me, or you can even text me in the chat box. So these were the four formula. On the basis of these four formulae, we will be doing a question right now. But before that, note down this energy portion. Q prime is the small charge that we have considered. Like total charge on the capacitor is capital Q, no Fahad? So the small charge, a very small portion Q prime has been taken. So that's why I've written it as dq, infinitesimal small. So that we can integrate it from 0 to capital Q to find out the total charge.
Okay, scroll button.
It will be 4 p.m. tomorrow, Wednesday. 4 p.m. tomorrow, Fahad. 4 p.m. to 5:30. KSA timings. The 11th class batch which I was referring to you for integration. Fahad, for your doubt, yes, you can use any of them. Like if capacitance and potential is given, so you can just use the second equation. If you have charge and capacitance, you can use the first equation. So according to your need, you can use all these three equations. As you can see, all the three equations are same only. We have just converted one or two into another form. Now, Zed's doubt, how you got the three equations. See, See, Z, from till here, is it clear? Q square by 2c, this integration portion. Till here, it's clear first. Yeah, okay. This is clear. How you put the values? See, Q is equal to CV. This formula you must be knowing. Q is equal to CV. So instead of Q, put CV. If it is Q is equal to CV, so Q square will be what? Q square will be C square V square. So I put C square V square instead of Q, and then in the denominator I had 2C. So in this formula I put this Q is equal to CV. I was left with half CV square. Then I wanted to replace this capacitance. Capacitance equals to what? It is equals to charge by potential. So in this formula, instead of capacitance I wrote charge, and since potential is in the denominator, it will go in the numerator. It becomes potential. So Q gets cancelled and it will be half QE. In this main formula that I have derived, Q square by 2C, I'm just putting the values of Q is equal to CV, whichever variable I want to replace. Like in this, I wanted to replace Q. So I put in this equation CV. In this equation, I wanted to replace capacitance. So I put Q by V. Okay. So if you people have written it down, let's just do a numerical firstly on the previous class that we discussed. See, note down this numerical first. And here only, yes, Fahad, see, you were asking about the numerical portion. No, here in this is a combined question because capacitance is not a solo topic. You know, energy is of the capacitor only. So capacitance and energy of this capacitor, both are linked topics. So this is a combined question. You have to find out the capacitance, you have to find out the charge that is stored, and you have to find out the energy if it is connected to a cell of 100 volt. Now parallel plate capacitor is there, area is 10 centimeter square, separation between the plates is 5 millimeter. Dielectric plate has thickness 3 millimeter. Dielectric constant is given as 2. Firstly, everyone should try for the capacitance part. See, we did 4 formula in the last class. One was C is equal to epsilon naught A by D. Second one was C is equal to epsilon naught A by D with a K. Third one was C is equal to epsilon naught A by D minus T plus T by K. And fourth one was C is equal to epsilon naught A by D minus T. 4 cases we have revised. At least who were there in the last class, try to find out of these 4 formula, which one you should use. Look at the separation between the plates, look at the thickness of the plates, then see which one is suitable. At least all of you should write me in the chat box number 1, 2, 3, 4, whichever is the formula suitable for this first case. Those who are new to this class or who didn't attend the previous class, you should also try. It's okay if it would. Correct answer, Fahad. Your answer is right. Others
Now,
also
what
try.
does T stand for here? T.
T stands for thickness of the dielectric slab. In the third one here. T stands for thickness of dielectric slab, and here T stands for thickness of a conducting slab. Madiha, see again, you have a dielectric plate also. Dielectric is there. Samia is right. Rifat, Reem, Madiha, look at your answers once again. Dielectric slab is there, firstly keep in mind. And then see the thickness of slab and compare the thickness between the plates, means separation of the plates and thickness of the plates. Zaid is right. Zaid, Madiha, now Madiha is correct. Madiha, Zaid, and Samia and Fahad. See, first one is used when, first formula, this is used when if the plates are completely filled with air. Here air isn't put. First, this formula you have to eliminate. Reason, because dielectric medium is there. This is valid for air. You cannot use this. And fourth one is valid for a conducting slab. Here you have a dielectric plate that is inserted. Yes, Sal, your answer is right. See, this is when a conducting slab has been inserted. Dielectric slab isn't there when we use this formula. It means we won't use this. Now, out of these two, because here also you have a dielectric constant, here also you have a dielectric constant. So how to choose? See, the thickness of the slab and the separation between the plates is not same. Yes, Zed, right, because of the thickness. You have the thickness of a slab. Means if this separation is 5 millimeter, then the thickness of the slab in between, this is 3 millimeters. So some space is there. It means this is which case? Third case. So now you know the formula, put all the values, and all of you do convert it into SI unit. Don't put as 3 millimeters or 5 millimeters. At least try for the first part and we'll discuss. Take time for 2 to 3 minutes, then we'll discuss it. And whoever gets the answer, you can text me. Yes, that is right, Fahad. But you have to not only write this, plus T by K is also there, and K's value is given as 2. And don't just write 5 minus 3. It will be into 10 to the power minus 3 as well. Millimeter is there, no? Milli you have to convert. Abhiya, is it getting clear? Are you able to understand this part, this question? Abhiya, Emin? Okay, wherever you get doubt, you can ask me. Fine.
Ma'am, what did you say for T? Like, what was it standing for?
Small t in third formula, that is the thickness of the dielectric slab. And in the fourth
Okay.
formula, it is the thickness of the conducting slab. So since there is no question of conducting slab here, that's why we are using third formula, and T stands for thickness. And D is the separation between them. Epsilon naught's value is 8.85 into 10 to the power minus 12. I'll write it. This is actually absolute permittivity of free space. This value, just remember it. This will be used. Meter square, Samya, meter square. SI unit is meter square. So it's given in centimeter square. You have to convert it into meter square. And what about you both, Sahal and Abia? Are your summer vacations going right now?
Yes, ma'am.
Yes, ma'am.
Right now.
Okay, both
Just
of
started.
they have started. Okay. 3 millimeters, yes, you have to convert it into meters. Yes. Because everything we have to take it in SI units. That's why whenever we discuss any topic, we always discuss its SI unit as well as the CGS unit. Just tell me, all of you, the way we had a class yesterday for 1.5 hours, can we have the last extra class tomorrow? Because there your vacations will be over from, I think, 10th. So next week we won't be having any extra classes. So can we have an extra class for completion of this topic, capacitance, tomorrow, so that in this week we can then start with current electricity? If anybody has issue, you can write. Timings will be the same. It will be because then Wafia will also be joining. No, Wafia is absent today. She was traveling. So it will be the same timings, 11 or 11:30, whatever suits you people. Suggest what are the timings that you people are available. 11 a.m. is fine. KSA timings, your timings. Just write yes if it suits you people. If you're not available on that time, just write no. According to you people, I'll have the extra class. If it's too early for you or you have to do some work, anything, just text me. 11:30, okay, 11:30, Madhya. 5 to 8 IST. 5 to 8? Z, 5 to 8. We don't have class tomorrow, no? Tomorrow is Wednesday. You have the next class on Thursday. What are you saying, Zed? 5 p.m. to 8 p.m. Indian timing. You don't even have a class on IST for extra class. 5 to 8. No, so your class won't be there between 5 to 8 IST. If it's 11:30 for you, no, if 11:30 a.m. is fine for you people, then it will be 2 o'clock for me. So if you're not available from 5 to 8, then it's fine. So I think most of you have agreed. Zaid, Abia, Madiha, Rifat, Samia. And what about you, Fahad? Fahad, it's okay. And who hasn't responded? Reem? Reem, did you respond? Rifat? Okay, it's fine. Okay, then we'll have a class. Did Rifat agree? Yes, Rifat has agreed. Fine. And Wafia was already available at 2 p.m. 2 p.m. for Indian timings. No. Okay, so it's 11:30. Just for tomorrow. Because then vacation will be over, no, sir. Then we won't be having extra classes. So 11:30 a.m. This will be Wednesday. And AM KSA. All right, let's discuss this as well. This question, parallel plate capacitor. So the calculation is lengthy. I know this calculation will take a lot of time because third formula is used. In the denominator, you have to put everything. So it's better if we leave it right now. You people can complete it in the next class, or you can complete it after the class and then show me the answers in the next class. So what was given? Thickness is, okay. So formula we are using, this is epsilon naught A by D minus T plus T by K. Where epsilon naught is this? A is what? A was given 10 centimeters square, I believe. A is what? A is 10 centimeters square. Yes. So this will become 10 into 10 to the power minus 4 meters square. D, small d is 5 into 10 to the power minus 3 meters. Thickness, T is equal to 3 into 10 to the power minus 3 meters or millimeters. And K is equal to 2. So in this formula, when you put everything, this will be 8.85 into 10 to the power minus 12 multiplied by area. D will be 5 into 10 to the power minus 3 minus 3 into 10 to the power minus 3 plus 3 into 10 to the power minus 3 divided by 2. This much farad. For all those who are not aware of, SI unit is farad. So this much farad. So you people can take your time and solve it. See, actually, it's not so lengthy the way it looks like, but yeah, it will take 1 or 2 minutes for you to solve this. You can take 10 to the power minus 3 common and then solve it. Your calculation will become easy. Second part asks you the charge. Charge stored and the energy stored if potential is 50. In denominator, first we there in the main formula that we did. Okay, D plus T minus. Okay, yes, Z. That was, I didn't see this. Thanks for pointing. How 10 to the power minus area, I'll tell you. So you just make a correction in this formula. First, I have written here by mistake minus. This first it is plus and then it is minus. This was written in hand. So just make the corrections and then solve it. This will be, and this will be minus. See, centimeter, we know how to convert. This will be minus. 1 centimeter equals to what? 1 centimeter. This is written as 10 to the power minus 2 meters. Fine. It is centimeter square. So this will be 10 to the power minus 2 whole square meters. That's why we'll write it as 10 to the power minus 4 meters. So it was, if 1 centimeter square is equal to 10 to the power of minus 4 meters, then 10 centimeter square will be equal to 10 into 10 to the power minus 4 meter square. Now tell me, is this clear? Okay, second part was asking the charge. This was the answer of the first part. Second part is asking us the charge. So you have the value of potential as 50 volt. New potential is given to us now. This is given as 100 volt. Okay. This is given as 100 volt. V is given as 100 volt. So Q is equal to what? CV. Whatever value comes from this multiplied by 100, you will get the value of charge, that much coulomb. Similarly, for the third part, energy, just write half CV square. V is given as 100 volt. C, you have to calculate it from the first part. So that will give you the answer for the second and the third one. So note it down, then we will discuss 1 or 2 points. Spherical capacitors we do. Just note down this. Whoever has not written it, not third part. In the second part only, it was given a charge and energy. So I just separated them while writing. Charge and energy. Both are in the same part where V is equal to 100 volt. So it's actually the second part only. Third part I meant by energy. Yes, yes, a separate notebook for physics, because then the rest of the things will get mixed up. So if you have everything separated for physics, then it will be easier for you to revise at the end, because derivations will be there, formulas will be there. Dielectric slab thickness. Just check the formula, everyone. Is it minus or plus first? Please check in your notes in your derivation this formula. Is it minus first or minus later? Just check in the derivation, because it could be d minus t plus t by k. Let's check it right now. This was d minus t plus t by k. In the derivation also it's d minus t plus t by k. This is the formula. See everyone, check once again. First minus will only come. I think here when I wrote it, no, again. This, here I had by mistakenly written it opposite. So this will be minus first and plus later on. So make a correction in the answer also. D minus t plus t by k. First it is minus, then it is plus. Sir, you can continue it from here. When we'll take the backup classes, or when you will be having the recording for the previous classes, then you can continue in the notebook only. Or after this chapter, you can start with the notes of the previous classes. But right now, you should write simultaneously with the class.
Okay, ma'am.
Capacitance value is coming 1.36. How much it's coming, Z? It's coming 1.36 into 10 to the power minus 13. Okay, I haven't calculated it. Solving this portion. See, just write it as 1.5. Okay, I'll solve it. To solve it, no, what you can do, you can take 10 to the power minus 3 common. So here in the numerator, you will have 8.85 into this. You can write it as minus 5 minus 4 plus 1. No, that becomes minus 3. And then 10 to the power minus 12, 10 to the power minus 3. That makes 10 to the power minus 15. And in the denominator, if you take 10 to the power minus 3 common, here you are left with 5. This sign, just reverse this sign. You're getting 6.5, 6.5 where? Now that's new answer there. So 5, this will also be minus. First it will be minus. Denominator after adding. Okay. So 5 minus 3 plus that becomes 1.5. So what's it's coming? It is coming 5 minus 3 gives 2. And then you have 2 plus 1.5. So how is it 6.5 then? Just check. Rest of you check. Denominator after adding 10 to the power minus 3 will be there. Others also see. What's your answer? Okay, sign you had taken the previous one. D minus T plus T by K is there, no? Just check once again. Okay, just check. Answer. See, this is what 8.85 into 10 to the power minus 15, and you can bring it in the numerator 10 to the power 3. Divide it. This will be, this is what? This is 5 minus 3 plus you have 1.5. So that will be 3.5. 8.85 divided by 3.5. 3 into 2 is 6. So it will be 2 point something. You will be having it as 2 point something. 8.8 if we divide it by 3.5, you'll be having it around 2.5 something. So not 1.5, 1.36 there, it will be around 2.5. Then into 10 to the power minus 12. This will be the value of capacitance, this much farad. All right, so then check your calculations. Now let's start with the spherical capacitors. Spherical capacitors, as we have discussed, spherical capacitors, and then I'll check that once again. Cylindrical capacitor one I haven't checked for your syllabus. I'll check it. But spherical capacitors is included in yours there, and for us, questions do not come on spherical capacitors. Just have the look on the derivation. By chance, if it comes, then you people should know how to derive the capacitance of a spherical capacitor. Let's say there are two concentric capacitors, spheres are there. The radius of the first sphere is R1, radius of the second sphere is R2. Bigger sphere means R2 is greater than R1. If plus Q charge is there on the smaller sphere, minus Q charge will get induced. Remember, most of you have studied induction with me. So charge will get induced. So it will be minus Q for it. Potential difference between the spheres will be what? It will be if, can anyone tell me, if charge is capital Q, radius is R1, what will be the potential on the sphere? Anyone? Yes, Samya.
KQ by R.
KQ by R. Which R? Two radii are there, no?
R1.
R1, yes. So it will be KQ by R1. And for this charge, it will be minus KQ by R. Now let's take KQ common. So what is left? 1 by R1 minus 1 by R2. This is left. Now if we put it in the formula of capacitance, capacitance is Q by V. Put the value of V. Q divided by KQ, 1 by R1 minus 1 by R2. So Q gets cancelled. If we solve the denominators, R1, R2 gets multiplied, divided by R1, R2 minus R1. Here, if we solve it, and K is left. See, final. K is what? K is equal to 1 over 4 pi epsilon naught. This is the value of the constant. So K can also be written as 1 over 4 pi epsilon naught R1, R2 divided by R2 minus R1. This is the formula of capacitance for a spherical capacitor. So numericals do not come from this. So that's why we'll also not practice numericals from this spherical capacitor, but others, two main formula questions are there. Two main derivations are there that we'll do in the form of question right now. But before that, note down this spherical capacitor portion. but do have a look on the derivation of it for your board exams. And numericals are important from your entrance point of view. From NEET and JEE point of view, spherical capacitors come. Done writing this part. Derivation of spherical capacitors.
Done, ma'am.
Okay. And others? Okay. Fine. As I was telling you, you have a derivation that we'll do in the form of a question. So let me show you the question that comes in exam. I'll tell you how it comes in exam. See, you have to calculate the force between the capacitance. Force we had studied in chapter 1, no, remember, where we had studied Coulomb's law and all the electric forces. So right now also you have to calculate the force between them. See, Q is the charge on the positive plate, minus Q is the charge of the negative parallel plate. D is the separation between the plates. Sigma is the surface charge density. Answer is 2.52 into 10 to the power minus 12 farad. Okay, Fat, yes. 2.5 to the exact answer. No, so okay. So all of you listen, the answer for the first part, that capacitance, it is coming 2.52 into 10 to the power minus 12. All right. Now see, sigma is the surface charge density. I am writing electric field for this one plate. Remember, in the applications of Gauss law, we had discussed applications of Gauss law when we were discussing. Then we had seen it is sigma by 2 epsilon naught for a single plate. In the last class also we had seen for a single plate it was 2 by epsilon naught, sigma by 2 epsilon naught. And for both the plates it was sigma by epsilon naught because 2 got cancelled. So for this plate, only this positive plate, electric field is sigma by 2 epsilon naught. Sigma's value, who is going to tell this? Rifat, do you remember what is surface charge density's formula? If charge is Q, area of the plates is A, and sigma is the surface charge density. Rifat, can you try?
Q by A.
Q by A. Yes, Fahad and Zaid are also right. Q by A. Correct. Surface charge density is charge per unit area. So this will be Q divided by A. Put it in the formula of electric field. It becomes QA 2 epsilon naught. This is the electric field. Now, from Coulomb's law, Madiha, can you tell any relation between force, electric field, and charge?
F is equals to QE.
F is
Force
equal
is
to Q.
charge.
Yes, right. Exactly. Now we are considering the force on the negative plate. Why? Electric field is of the positive charge. Now force is being generated on the second plate. So second plate is having what type of charge? Second plate is having the negative charge. So if we write it, the complete vector, it will be minus Q multiplied by the electric field. This is the formula, no? F is equal to QE. This I think we all have done. Zed, I have done it with you as well. Remember electric fields formula I told you, force by Q. From there, if you are able to recall it. So force will be equal to what? Put the formula of electric field from here. It will be minus Q multiplied by what? It will be QA 2 epsilon naught. So formula of force, you get it as minus Q square by 2A epsilon naught. Now, if you get the values like A is the area of plate, Q is the charge, and it asks you the force, then you can directly use this formula. So don't consider it as a separate question and not need to learn this and just learn the steps. No, you have to learn the final answer as well. It can come as a derivation, it can come as a formula based question also. What is the force between two parallel plates capacitor if charge is so given and area is so much given? Just put it into this main formula of force. All right, so we had done it in the form of question, but it's a kind of derivation. One more is left, but first note it down. We are taking minus q because we are writing the complete vector. Whenever you have to write down the magnitude, then ignore that negative sign. Just write q square by 2a by epsilon naught. Okay, so the next one, this is the last one. Energy density between the plates of parallel plates of a capacitor. Now, energy density is what? Energy density means energy per unit volume. When we'll reach current electricity, there you'll see you have a term known as current density. That has a different meaning, there we'll see. So, energy density is basically energy per unit volume. So, let's say two parallel plates are there, area of the plate is A, separation between the plates is D, and the charge of the plate is capital Q. Energy we have already studied, so we'll be using the energy half q square by c. Again telling this is a derivation, this can come in the form of derivation as well, and it can come in the form of a question as well. So if it comes in the form of derivation, proceed in this manner. Energy density is equal to energy by volume. Energy is equal to half q square by c. Then write volume is what? Volume is always area multiplied by the thickness. So area is A. Thickness means the separation between the plates. That is small t. This is the energy that we had derived today only. Q square by 2c. Volume is A by D. Now let's put it in the main formula of energy density. This will become Q square by 2c. And instead of volume, you have A D. See, value of C for air. Samya, can you tell what is the value of capacitance if air is filled? Nothing is mentioned. What is the value of capacitance that we take? Samya?
Epsilon naught A upon D.
D. Yes, epsilon naught A by D. Right. Epsilon naught A by D. Let's put it in this. So energy density will become what? Q square divided by 2 AD is there. And instead of capacitance, we are writing epsilon naught A, and this D will go in the numerator. See, D gets cancelled. What are we left with? Q square divided by 2 A square epsilon naught. Few minutes back, Rifat answered that Q by A is what? That is the surface charge density. So if sigma is equal to Q by A, then sigma square will be equal to Q square by A square. So here you have what? Here you have energy density as Q instead of Q square by A, this term. Instead of this, I can write it as sigma square. Sigma is surface charge density, surface by area. This becomes sigma square divided by epsilon naught. Now, if I multiply it and divide it by epsilon naught, see what it becomes. It becomes half sigma square divided by epsilon naught square multiplied by epsilon naught. If you just divide and multiply it by the same term. Now see, electric field is what? Electric field is basically, here your energy density is what till now? Half sigma square by epsilon naught square multiplied by epsilon naught till now. Now electric field is what? I've told you, for a single plate it is sigma by 2 epsilon naught. Since two plates are there, it becomes sigma by 2 epsilon naught plus sigma by 2 epsilon naught. That gives you epsilon divided by epsilon, sigma divided by epsilon naught. 2 2 sigma divided by 2 epsilon naught is equal to sigma by epsilon naught directly. So electric field is sigma by epsilon naught. So E square will be what? Sigma square by epsilon naught square. So instead of this term now, we can write this as electric field square. So see what's your formula becomes now. Final formula of energy density, this is mu is equal to half E square divided by 2 epsilon naught. Now this shows that energy between the plates of the capacitor depends on the electric field. So energy density is proportional to which quantity? Energy density is directly proportional to the electric field. This is one of the conclusions from this derivation. This can come in the theory line also. It can come in the form of numerical also. Electric field will be given. Just put it in this formula. Whatever value of electric field will be given. Just put it in this formula. Epsilon naught you people know already. And what else can come? And derivation can come. Yeah. So all these 3 things can come. Just note it down before that. And if wherever you get stuck, ask me. Just to get it in terms of electric field. If we do not multiply it with by epsilon naught in the numerator and denominator, then we won't get sigma by epsilon naught whole square. So just as to get the electric field, because energy density by theory, it is directly proportional to electric field. So mathematically, to show that we have electric field, to get electric field, we are taking sigma by epsilon naught. Just text me done when you people have written it down. Yes, Fad. Questions can come. Like I told you, no, if electric field is given and energy density is asked, just put it half into electric field's value, square of it multiplied by epsilon naught. Epsilon naught, you have it as 8.85 into 10 to the power minus 12. So formula based question will come. No tricky question will come from it. And what about others? Rifat, Zaid, and Samia have done. Abia has completed. Is it Abia or is it Abia?
Ma'am, it is Abia.
Abia. Okay. What about Madiha and others? Ahad, Sahar done. Okay, fine. So I'm stopping here today. Tomorrow, let's have an extra class. And I'll discuss the backup also with you people, new students. I'll discuss the backup because one more student, most probably she'll join tomorrow also. So let's have a class, 8:30 a.m. KSA time.
Ma'am, the class is at 11:30 in the morning.
Yes, in the morning. Any
Okay,
issues?
No.
Okay, fine. Okay, so we'll continue tomorrow. Okay, take care. Okay, Allah Hafiz.